All right, what's up, everybody? Welcome back. Today we are going to start in on chapter two. Chapter two is on what we call transformations. So this first lesson, lesson number one, lesson 2.1, is going to be a lot of definitions, very similar to what we saw in lesson 1.1, all right, the first lesson of chapter one. So just a reminder, if you go over into Canvas, I've put in on your homepage, I have put in a new module, chapter 2 notes. Okay, so remember, you can always click here to find your notes. You can either download them so you can write them. Please ignore that says 4.1. At my old school, this was chapter 4 and not chapter 2. I'll make sure I change that. But you can download and use these notes as you follow along with the video and follow along with the PowerPoint. Okay, our objectives today is to identify and name isometric transformations, translations, rotations, and reflections. Okay, a transformation, just some basic vocab. A transformation moves or changes a figure in some way to make a new figure. Okay, isometric transformations. Isometric transformations, ladies and gentlemen, is the most important one. That is what we're going to be focusing on in this chapter. You're going to learn what non-isometric is, but you're mostly going to be tested on isometric. So isometric is a transformation where the shape does not change shape or size. It just moves to a new location, but the shape and the picture itself stays the same. Non-isometric is a transformation where the shape does change shape or size. Okay, the image versus the pre-image. The pre-image is the shape before your transformation. The image is the shape after the transformation. You can always tell which one is the image because the image is written with the prime symbol, a little like an apostrophe, right? This was our pre-image lightning bolt ABC, and then it transformed over here, and now this is the image lightning bolt A prime, B prime, C prime. And if we were to create a new lightning bolt and it went over in this direction over here, and now we have a new lightning bolt. Obviously, Mr. Stanton is incredible at art, right? We would call this now, since it's now the second image, we would put a double prime. So we'd put two quotations, B double prime and C double prime. Okay, we'll get more into that later on. But image versus pre-image. Pre-image is before, just regular letters. Image is after, and it has the little prime symbols. Okay, so which of the following are isometric transformations? There are multiple answers. Go ahead and pause the video. Think to yourself, what are those answers? Good, pause. Let's take a look. This is our pre-image. Okay, is A isometric? It is indeed. It stays the same shape, same size. It is just flipped over. D is not. We can see that it has gotten smaller, right? It did change shape or size. B is correct. We see that it just flipped across. Okay, E is basically the same thing as A. It works. C, we can see that it gets squished, right? So it changes shape and size. And F works. It just got rotated. All right, so A, B, E, and F work. Down here, number 2, pause. Good, let's go. Pre-image. A works, does not change shape or size. D does not work, clearly got bigger. B, just not even close. This little angle got squished in here. E is a tricky one. You can see that this line right here is a little bit diagonal, but this line is a little bit more straight up. Notice that if it was stayed the same, it would have been more like this. So E is a no. C does work. It looks exactly the same. Doesn't look like it's changed at all. And F we see is much smaller, so that does not work. So remember, isometric does not change shape or size. Okay, the first type of transformation that you're going to learn in depth about next lesson is called a translation. Translation moves a certain distance. Think of the pre-image just sliding to a new position. Okay, I always like to think of translation. It has SL here in translation, and translation is like a slide. Okay, every point in the shape moves the same distance, right? So if we think about this on a graph, the shape is going to move some distance in the X direction going side to side, and it's going to move some distance going up and down in the Y direction. Okay, for this specific example, right, from A to A prime, it moves 1, 2, 3, 4, 5, 6 spaces. Notice it just to the right. That is in the X direction. Notice this does not move up or down at all. So it doesn't move at all in the Y direction. But they all move the same. B moves 1, 2, 3, 4, 5, 6 spaces. And C to C prime moves 1, 2, 3, 4, 5, 6 spaces. They all move 6 to the right in the X direction. So the way that we would write that is XY changes to X plus 6 because it's moving positive 6 in the X direction, Y plus 0 because it doesn't move at all up or down in the Y direction. Again, we'll go more in depth on this next lesson, but make sure you're writing down these definitions. Okay, reflection, the pre-image is flipped across a line of reflection. Each point moves different distances now, depending on how close to the line of reflection is. Okay, so this one's a little weird. Think about a reflection. You're in a mirror, right? Here is your line of reflection. They move different distances, but in a way they also move the same. Notice these are not labeled. Let's label these real quick. This is point, that's a terrible color. This is point A, this is point B, this is point C. Notice A is 2 points away from the line of reflection. So on the other side, it's 1, 2, and we would name this A prime. Okay, but sometimes they move different, right? B is moving 1, 2, 3, 4, but on the other side, it's also moving 4. So technically it's more than 2, but it's still moving the same distance on the other side, 1, 2, 3, 4, and we would call this B prime. Same thing with C. C is going to move a different amount of distance compared to A and B, but C prime is going to be the same distance as C. 1, 2, 3, 4, 5, 6, 7. So on the other side, it's 1, 2, 3, 4, 5, 6, 7. And we would name this C prime. You guessed it. Don't forget about those prime symbols. Rotation, it's a circular movement around a central point that stays fixed. Okay, points move different distances depending on the type of rotation, right? So you can see B over here to B prime is moving the same amount of degrees, but it's moving a different distance. We can see that this arc here of distance is going to be much different than A to A prime, which is a much bigger arc. But technically, it is still moving the same degrees. If you think about it, if you tilt your head a little bit, this here creates a right angle. So that means this triangle is being moved 90 degrees, okay? Again, we'll learn the more specific rules in those when we go in depth. Remember, this is just an overview of all the different types of transformations. You will be going more in depth in further lessons. Okay, so those are the 3 types of isometrics. Those are the main 3 that we're going to be focusing on in this chapter. This next section is more just kind of like fun facts. You will learn about these in a different math class, not here in geometry. Non-isometric transformations, the transformation does change shape or size, right? So it gets bigger, it gets smaller in either 2 directions or 1 direction, right? Think about this doll shrinking or like this up close hyperlapse of mushrooms growing, right? They change in shape and in size. Okay, a dilation makes the pre-image smaller or larger, but does not change the overall shape. Think about your eyes when you're dilating, right? They're getting bigger and smaller, but it's still the same circle, just a different size, but it's not changing the shape. Okay, same thing, same shape of a car, but it's just a little car with this kid riding in it. And I just think that this guy riding this bicycle is super impressive. Look at that, how tiny that thing is. And he just hops on, he's like, all right, let's go for a ride. Here we go. Anyways, right, here's another example. Notice the triangle ABC is getting bigger to triangle A prime, B prime, C prime, but it is still the same triangle in its shape, just not its size. Okay, a stretch, when the pre-image is made smaller or larger in only one direction, either horizontally or vertically, right? Notice one thing you can really tell on a graph, notice this triangle, point B is at 4, point C is at -1. We can see that from our triangle ABC to triangle A prime, B prime, C prime, The image is definitely bigger, but notice B is still at 4 and C is still at -1, right? It only got bigger horizontally. It did not get bigger vertically. And one way I like to show that, think about like if you're making presentations or you have a picture or whatever, right? You can change the picture by dragging the corner, right? That technically makes it, notice how it's getting bigger horizontally and vertically, right? It doesn't really change the picture at all. That's still the same cat. It's just a little bit bigger, but it still looks exactly the same. However, if we take it on just one side, right, and we just stretch it horizontally, notice that is now the image looks way different because it just got stretched in one direction versus two directions. Cool. So in your own words, this is on your notes. Write down a way to describe the following transformations. Pause, write them. Personally, I would say a rotation is like a spin. A translation, I would say like a slide. Oh, not slide. Okay. Also, another way I like to use translation. Translation just simply changes location. Translation change location. It rhymes, so you know it's real. Stretch, I would say, change size in one direction. It changes size in one direction. Reflection, I would say, is like a flip or a mirror, or things like that. Dilation is just, for me, I would just use big or smaller. Big or small. Those are my personal preferences. Again, right? Studies show that if you put things into your own, put definitions into your own words, you're way more likely to remember what those means. Whoops. Okay, here's just some examples. Thanks to practice. Remember, isometry or isometric means that it does not change shape or size. So choose if your pre-image and your image, is it isometric or non-isometric? Did it change shape or size? And then what specific type of transformation happened? All right, so here, take a look. From your pre-image to your image, definitely changed shape or size. So this is non-isometric. Notice it only got bigger horizontally. It did not get bigger vertically, so this is a stretch. Here, does it change shape or size? No, looks like it's the same shape and size, so isometric. Here we see it just turned a little bit, so that is a rotation. Okay, same thing, change or shape or size? No, it looks same shape and size, isometric. Here, notice this guy looks like he's looking over here. This guy looks like he's looking over here. So they're looking at each other. So this one here is a reflection. Okay, just some more examples. This first one definitely changes shape or size, so that's non-isometric, but this time it gets bigger horizontally and vertically. So this here is a dilation. This one does not change shape or size. That means it's isometric. And this one, it doesn't rotate, it doesn't flip. All it does is just go over to the right and down a little bit. So this is a translation. It slides. Okay, this one very clearly gets smaller. So that's not isometric. And this doesn't, it gets smaller both horizontally and vertically. So that is a dilation. Good, just some other examples now with triangles. Okay, same size, same shape, isometric. Definitely goes up and definitely goes over, so that is just a translation, doesn't turn or anything. This one, also isometric, but this one definitely rotates. Same thing, definitely isometric, same size, same shape. This one is a reflection. And one last one we'll do. Okay, here to here, definitely isometric, does not change shape or size. This one is a reflection. All right. This one here definitely gets bigger, changes shape and size, not isometric. Notice it does get both taller and wider. So this one here is a dilation. Okay, the last one definitely changes shape or size, so not isometric. But notice this is 1, 2, 3. This one over here is 1, 2, 3. All right, so it doesn't change vertically. It only got bigger horizontally in one direction, so that is a stretch. Please reach out if you have any questions, need anything. I will see you in class. Please prepare, or hopefully you watch this video, and we will be ready for our assignment in class. Have a great day. Go Mustangs.